The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. Thank you for joining. My name is Chris Parsons from Critical Manufacturing. Welcome to the third webinar on our webinar education series, Upgrade to Industry 4.0. This series is designed for manufacturing consultants who specialize in MES applications and factory automation, who are helping their customers with the challenges of a changing world. With Industry 4.0 and smart manufacturing becoming a mainstream topic, we're committed to providing manufacturers of complex products from high-tech industries with the most complete Industry 4.0 ready MES as the foundation of their digital transformation strategy. As you all know, MES is a long-term investment for manufacturers. And companies that are transitioning to smart manufacturing technologies must not only meet their own requirements, but the increasing demands of their customers today and for the future. In our previous webinars, we discussed why a new generation of modern MES is the essential foundation for Industry 4.0. We also discussed 3D factory visualization and manufacturing digital twins. On today's webinar, we will talk about MES and the Industrial Internet of Things, IIoT. Here you'll see the agenda for today. Following this brief introduction and a few logistics, we have the pleasure to host two speakers who will discuss how you can accelerate business value for your customers with Industry 4.0 ready MES. Francisco Almada-Lobo is CEO of Critical Manufacturing and is a high-tech manufacturing expert and accomplished business leader. Francisco has vast experience of implementing MES in complex manufacturing environments, especially in the semiconductor industry, where he worked for manufacturers such as Siemens, Infineon, and Commando before co-founding Critical Manufacturing in 2009. He is a recognized Industry 4.0 educator and evangelist, having spoken at more than 40 Industry 4.0 events in the past year. Our second speaker is Bernardo Ospina, Critical Manufacturers Director responsible for our global channel strategy. Bernardo has many years' experience with both ERP and MES applications and helping businesses grow through effective channel programs. Bernardo has worked closely with many solution integrators and consulting organizations and will present an overview of how you can benefit from Critical's innovative approach to IIoT and Industry 4.0 manufacturing capabilities. Before we start, just a few housekeeping items about the webinar today. You will see a panel on the right-hand side of your screen. You can select the orange arrow at the top to open and close your panel, and you can also control your audio connection. Most importantly, you can see a box where you can type in and submit your questions as you think of them. We'll be answering questions at the end of the presentations today, and we want to make sure that we provide answers to you in an efficient and detailed way. If there are more questions than we can cover on this webcast, we'll provide answers by email as quickly as possible. This webcast will also be recorded and will be available to view on demand in the coming days. We'll be sending a link to the recorded webcast to everyone that registered to view today's presentation. Again, please don't forget to submit your questions. And I'll now introduce our first speaker, Francisco Almada-Lobo. Francisco.
Thank you, Chris. Welcome everyone. I would like to start this topic about the MES and the importance of MES within the IoT. But first of all, talking about the IIoT, the Industrial Internet of Things, and we start by defining what really IoT is. So the Internet of Things term refers basically to the connection of devices, what we call the things, through the internet, so they can collect and share data without human assistance. The IoT devices, they range from smart sensors to mobile devices, vehicle systems, and so on. Even people can be outfitted with sensors connected to the internet. But then the IIoT is actually the use of IoT technologies for industrial purposes, from gas pumps to HVAC systems to machinery on the factory floor. It's quite interesting that the idea of the industrial devices exchanging information isn't new at all. You know, the persons that are dealing with this have been doing this for years. But the IoT, however, brings this to an entirely new level because it provides a system and standards for universal interconnectivity over IP, over the Internet protocol. While many currently networked industrial devices are today closed systems, they can only communicate to the devices that the same network or that speak the same language. For instance, the same protocols or the same architecture. But the IP-enabling devices, with IP-enabling devices, this potential for interconnection over the existing network infrastructure is really vastly expanded. But there's more, you know, much more, and that's why the IoT is so important. The devices are getting so small and so cheap thanks to the evolution of electronics and the famous Moore's law, that, you know, these can be now attached with virtually any element in a manufacturer. Materials, products, containers, beyond the equipment, of course, people, and can leverage location-based services. But, you know, while for equipment, this is becoming more common, the Industry 4.0 and the use of IIoTs are opening up a completely new front, which is the use with the products. So by attaching an IIoT device to a product, regardless if this is a product already produced or still work in progress, or even before any transformation step happened, we can add up intelligence because the electronics of this device will allow computing, awareness because there are sensors, like temperature, pressure, vibration, connectivity, etc. And they'll be able to connect to the internet via Wi-Fi or connect via Bluetooth or NFC to other devices or machines. And also they'll become responsive, meaning that the products or the IIoT will be able to change their characteristics based on external instructions. So these are smart products, which is a category of cyber-physical systems. Now, these smart products, before they've actually been built, they will have already the complete spec of the to-be product. But beyond that, they will know exactly which are the production steps that are necessary to be applied to itself so that it can be built. So it's quite interesting. And at any point, they know which steps have been performed, which ones are still left, and they'll know what the actual production cost already incurred is. This self-awareness and intelligence, these are the basis for the autonomous systems in the shop floor. Then, at the same time, the manufacturing equipment is also sensorized, has also computing power, is also connected and responsive, exactly the same. And it is a smart equipment, or a special case of a cyber-physical system, which we call cyber-physical production systems. And then the cyber-physical production systems will then equally know exactly, what are the processing steps they'll be able to produce. They will know the material classes they can operate with. They'll know what recipes they can use. They'll know when they'll have to go on maintenance, and they know the cost of every operation as well. And then they will basically be these cyber-physical production systems, and together they will form the two types of cyber-physical systems will form the basis for the smart factory. And in a smart factory, the shop floor will be essentially decentralized, working with the autonomous cyber-physical systems, communication with each other, and self-organizing the shop floor in what we call a decentralized manufacturing marketplace. This is interesting, possibly subject to another webinar, because the traditional optimizations will not work in this environment where we're going to have basically one-off products and all of these autonomous entities. But to today's point, in addition to the communication between the product and machines, these different cyber-physical systems based on all the data they'll produce, this will allow the creation of what we call the digital twin. We'll be able to have an exact representation of the factory in a computer, in a tablet or smartphone, regardless where we are. We can do this from home if you want to. And we'll not only be able to visualize those elements, but also through the same system, we'll be able to get status, to get performance indicators, to get historical values, future plans, etc., related to all these entities. And then with external commands, automatic or manual decisions, therefore having the virtual influence on the physical world, we can influence it. For instance, we can provide instructions or actions. We can stop a machine, start a machine, move an AGV, send a recipe to the equipment. And these two worlds, the physical and virtual, they will allow as well an enormous amount of extraordinary scenarios of virtual and augmented reality. And also the amount of data collected will be very, very important to improve decision making, both online and offline. But we'll only be able to take advantage of all this future if we implement solutions which are not isolated and they are part of the overall shop floor system infrastructure. This is what I have here is an example of a digital twin created using Critical Manufacturing's Fab Live, which will be able to represent, the real-time status of information, all the entities of the shop floor, all these products, containers, parts, personnel, etc. And of course, when available, using location-based services. Then this digital twin is the basis for the virtual reality. And as we talked in one of our previous webinars, the scenarios using virtual reality will be very important for training or for simulating real environments for planning reasons, for instance. So there's many scenarios in which these are useful. But the greatest of the advantages will be the use of augmented reality. So these augmented reality scenarios in the shop floor is where we'll be able to superimpose virtual information on top of what the camera of our device is capturing. In this, although we associate this immediately to Google Glasses or something like this, will not only work with VR glasses, but with other devices. So, for instance, some of our customers are using it with tablets or industrial smartphones, for instance. But getting to the point in which we can leverage really the IoT data for these scenarios, this is the real question. While there's a huge number of what are called IoT platforms, and this increases on a daily basis, manufacturers have to take the decision on how to get prepared and basically leverage this revolution. And I've been seeing a lot of bad investment decisions by all of a sudden ignoring basically the evolution of manufacturing-related software systems anchored around some basic principles, like, for instance, not creating isolated islands of information, not generating redundancy, and making sure solutions do talk to each other. So some quick basic principles are shown here in terms of the main core software solutions in manufacturing. So while PLM focuses essentially on the creation of products and understanding how these will be produced, the ERP focuses on the customer orders and therefore defining what needs to be produced. And the MES manages the shop floor physical and business workflows. It controls production, manages products and assets, collects data, ensures compliance, and optimizes production among other functions. So this basically makes the MES the ideal controlling platform for future IoT coordination, since the IoTs cannot all of a sudden be treated as elements that run completely separately from the processes that they are meant to help control and also gather data for. So when to collect data, how frequently, what should happen to this data are extremely important questions and decisions which need to happen considering the underlying manufacturing processes. But there's more, and even equally important at least, the data which is collected, this data has no context. So we can certainly collect data from sensors and analyze profiles, say for instance of data temperatures, and send these to big data or machine learning algorithms. And there may be some value in doing this, but it will for sure be no more than a fraction of the value that they could be obtained if the data is properly contextualized. What I mean is, for instance, if this machine temperature that's being collected, the info on when did it go on maintenance, which product is being produced, which recipe is being used, what are other related data collections, parameters, classifications, regardless if they were done manually or automatically, which have been done. All of this is information, and extremely important. And all of this information, properly contextualized, this is then of enormous benefit when used with the appropriate business analytics techniques. Therefore, we believe that the MES played a central role in gathering data and controlling information from and to manufacturing equipment. And that's why we had previously created a module which we called Connect, which would perform this bidirectional communication and integrate it into the shop floor processes. And now, with IoT devices, beyond just the standard equipment interfaces, makes this even more important because of the amount of data, the amount of processes, and the amount of decisions that need to be made will grow exponentially. And therefore, it's not really smart to make this run completely in parallel. So we have decided to create a new evolution of our Connect module. And this is something that we have released as part of V6. So just a few words on this. So we wanted it to be, first of all, an evolution and not a new product, because these solutions continue to work with standard interfaces like OPC for interfacing PLCs, for instance. And this is extremely important. And also one of the reasons a new completely parallel IoT platform won't allow taking all the value from this setup, because no factory will work entirely on IoT devices. And even more, the IoT interfaces, they are really in their infancy, and it's of great importance that these standard interfaces can work side by side, these IoTs, and that the platform treats them exactly the same way, allowing potentially cooperation or allowing a smooth migration whenever appropriate from one to the other. But there were additional challenges that we tried to cope with as well. In the idea that in the past we could run the entire Connect solution in the same hardware box, but the IoT, they may have protocols that require co-location. Like for instance, one of those is the Bluetooth Low Energy. And many solutions, IoT solutions, will come in their own hardware boxes. So we will control which automation workflows and drivers get there. But the idea is that they will run in almost any type of hardware, reducing costs compared to other alternatives. Another very important point is the security. So in this model, we control through a central gateway which links shall exist between the factory and the outside world. So we will not connect IoT devices directly to the cloud, like many different platforms. Because this will raise enormous security concerns. It will be possible, of course, to hack the system, completely stop the production floor, or even worse. And even beyond all of this, we wanted this new Connect to improve on several aspects, like allowing an easy configuration of automation scenarios, to be easy to debug them, centrally control, and also deploy the automation elements at once. So therefore, replacing the workflows or the automation workflows without having to change the driver and with minimum downtime, for instance, is another of the considerations. So a few explanations about the architecture, and I will not try to go too much in detail in terms of technical aspects, but the main idea is that the Connect IoT will basically run at physical hardware next to the equipment, and what it actually runs, the drivers and the controllers in this drawing are specified at the MES level, and then they are deployed from the MES into this local physical hardware so that they can run there. So first, the driver is a low-level process that communicates physically with the device using protocol-specific methods, and then reports the events from the device into the level above, which is the automation controller. This is where the OPC or SecGem or Bluetooth Low Energy, MQTT, these are some protocols. This is a level where these protocols work. Then above, we have the controller or the automation controller. And this is an event-driven process that executes soft workflows in response to events coming from the driver. And of course, commands coming from the external world. An automation controller can communicate with more than one automation driver, although in this example, we have one-to-one. Finally, the automation manager, which is represented there, this is a software host process responsible for spanning and controlling the automation-related processes. So this is kind of an operating system for the equipment integration. So, going a little bit more in detail, the monitor is a process that determines which processes must be started, downloads and manages the packages as needed, starts automation processes, monitors the health of the automation processes. Then what else do we have? We have a repository. So repository is a storage location that's used to distribute the software updates for the automation controllers and drivers. And finally, we have a gateway, which is this process that acts as a router or bridge between the processes in a local network or in a remote one, such as the cloud. So, not wanting to go too much in detail here, what is important is that what we'll actually do, is like in this picture, we are now at the MES configuration level. And what happens here is that we are creating the automation workflows, which will then be sent, deployed to the local hardware where they should run. So these workflows consist of tasks, which are dragged and dropped from the bar, the one that you see on the right. And the different drivers and protocols, they have different colors so that they can be distinguished. And the possible tasks are made available by the underneath driver. For instance, on this screenshot, the blue task is a blue task for the SexGen driver, which is used in Semiconductor. And this is, in this case, a state change event. So in this example, there's two additional tasks, one which is a logical task, a switch, and an MES function, which is adjust state for basically changing the equipment state from the model available at the MES level. So what this does is that when there is an equipment state change event at the equipment, we will change it at the MES level. So again, what's happening here is that the events will trigger these workflows that will consist on sequences and branches of workflow tasks, and the automation driver configuration will define which events, methods, and properties are available for the workflow. So while we are drawing these workflows, there's absolutely no coding involved. So we're saving and made those available to the instances connected to the controller version. And the idea is that the equipment automation workflows are really to be done by automation engineers, by power users that will just, without any code, drag and drop elements, and these elements encapsulate logic and abstracts the low-level details of the driver. And also, this platform is open in the sense that additional objects can be created by customers or by partners, and again, encapsulating some logic. And these blocks are then reusable across different automation workflows. And then even better is that the workflows can be debugged here at the configuration level. So, we are at the MES configuration level and we are debugging those. So we can simulate variables, we can simulate inputs from equipment or from the IoT without the need for external simulators. So for everyone who has done this type of work before, you understand the burden that you have to go through to use, or even sometimes having to create one later to debug the workflows. And also even beyond that, we're working in an even newer version, which will be able to debug the workflows in real time with real values coming from the equipment interfaces or from the IoTs. So then, once we have done this, the extremely important benefits from this overall architecture is that now we have the centralized ability to, after having performed these workflows, do the deployments or do the upgrades with a one-click deployments through the integrated device management solution. So again, regardless if we're using standard interfaces like OPC or IoT devices, it allows a total and detailed control over versions of the entire full stack of controllers, drivers, automation workflows, and master data, which are deployed into the physical hardware where this will run. And this can be done all at once through a mass deployment or selectively with rollback possibility, but saving an enormous amount of time compared to any other solution that we've seen so far. Then, of course, finally, in terms of protocols, we provide an extensive set of available ones, including the more common PUs with PLCs, which are the OPC UA and OPC DA, the SexGem for semiconductor, the ones that are more related to IoT devices, which is the Bluetooth Low Energy or the MQTT, and also for working with legacy equipment that's still exists quite frequently in different facilities, an interface for file-based or database when this is the only possibility that equipment have. And also, of course, it's possible to add own specific protocols and then make this available throughout the entire solution. So we're launching this for customer of ours in semiconductor, one electronics, medical devices, and one in automotive. So far with quite good results. So the Connect IoT is the new V6 equipment and IoT integration module, which is part of the Critical Manufacturing's modular MES portfolio. For the ones that might be seeing this for the very first time, this is the current set of modules that our solution has. They have been grouped in suites for convenience, like for instance, having the sampling, SPC, document management, and exceptions management, which is our Kappa solution as part of the quality suite. But all of these are separated licensed modules that can be deployed, and once activated, they are completely pre-integrated into the overall solution, allowing 5, 6, 7 of these models to work within a specific scenario, for instance. And then, because this is important for our partners, because some functional modules have really much more functionality than what you could expect just by reading the title. We have created these solution maps where, for instance, you can see that maintenance management includes maintenance, calibration, and tool qualification, as an example, or labor management, which includes operator training and certification, shifts management, shift logbook, all within the same. Here you also see that the Connect IoT will come with all these different protocols that I mentioned before, SexGem, OPC, and so on. And one additional information which is very useful when we're talking to potential customers is that the pricing for this Connect IoT is done only once, and therefore it does not increase based on number of connections, sensors, equipment, or any other factor. Like, for instance, what happens to all our different modules, which also don't vary based on usage or number of users or any other factor. So these are priced once and the value is maintained. Regarding the solution map, and because there's functionality in pre-configurations, which are done by industry, we actually have these solutions specifically tailored to our main target industries. For instance, we have one specifically for medical devices as an example. So good. So when it comes to the discussion of analytics, which is the next part when you're talking about IoT, and because it's a very hot and confusing topic, we have defined this model of analytics that I'd like to share with you. So we have the online, which basically deals with online information. This is where historians typically happen, where we have trends, where we have alarms. This is the online. We have a second level, which is the advanced level, where we have a little bit interactive. We can have dashboards with widgets. We can have reports that customers can extend. We have customizable metrics and KPIs, and we also have complex event processing, which I'll explain a little bit later today. The third level is then the reactive analytics, where we start having data cubes aggregated according to dimensions so that we allow slicing and dicing operations, and this is where the majority of the statistical analysis occur. And then we have the final, which is the predictive analytics, and this is the use of machine learning for building models, doing simulation of scenario planning, and this is where, in case the data sets are very extensive, we can use big data by scaling the solution into several hardware. So as part of our standard product, we have a business intelligence framework that we made available to our customers so that they can operate with this directly using Power BI, which is very useful. I think I have a picture later on. or using Excel if required. But then we have more advanced functionality like data mining, OLAP, and reporting. And we also ship the system with already a set of pre-integrated R services that can be also extended. So for instance, in an example of our entire advanced analytics suite, the same level of information, you can see this in analytical reports in Excel, using these interactive reports, like in this case, using the Power BI. And this is very interesting because we have our customers working with the data and the reports, and in this case, the Power BI reports that we provide them, but then they can build things on their own. And it's very interesting how they really get the ownership of these solutions from a certain point onwards. And this does not require any type of specific SQL or skills in order to do that. You have the paginated reports for official reports, which again can be extended. And we also have now the mobile reports, which come with Microsoft solution. And this is a formerly DataZen for the ones that know this from those times. So some final slides about the future. And this is important because our products will keep evolving. And the IoT datasets are opening a lot of possibilities. So I'd like to, very quickly give you some quick insights about where this is going. And the first aspect, which is also worth clarifying, is that we do have today in our products the analytics side, where we apply different BI solutions mentioned. But we also want to provide a lot of functionality, for instance, for having flat structure export mechanisms so that IoT equipment or MES data can be used in big data like Hadoop, for instance, allowing this linear scaling of the solution to cope with these huge data sets and allowing the use of third-party solutions. And then we'll also start using machine learning solutions to enter the world of predictive analytics. And so, we already have some prototypes and some examples which are really interesting. And we are actually starting with maintenance, because this is an area in which benefits can be more quickly obtained. But also here it's worth explaining a few concepts real quick. So upon collecting data and training big data sets over a given period of time, the idea is to be able to have the system which upon new data and, for instance, a specific failure, it can describe what happens. Is this a failure or not, and of which type? And then the next level is the diagnostics, meaning we'll explain why a particular failure happened. And this is already very important information. It will be already worth it. But the real value comes when predictive analytics are used. So upon values collected, this should estimate a given probability of failure at the machines. What we are envisioning is that in the prototypes that we're doing is you should, for instance, for maintenance technicians, have a map with multiple maintenance activities to be performed. Then in the same map, they will see what are the probabilities that those machines will break. And this will allow them to either anticipate the maintenance for those machines that are about to break, or even delay others that have a low probability of failure. So in both cases, having significant tangible benefits. And finally, the last level, of course, is the prescriptive, through which we not only know the probability of the failure, but we'll know how to eliminate it. All of this will take time, obviously, but the structure we're implementing has these levels that are shown here in this last picture. So the data that is collected from devices, machines, again, always machine and equipment and IoTs, this data will be processed immediately using this technique called CEP, or complex event processing. So this is a technique that uses this in memory. So we will basically perform this processing even before the data is stored. So the idea is to detect immediate patterns, level deviations, and then based on these produce alerts or automatic actions. So that's one level, the first level. The second one, the data from the IoT will all be stored in an IoT database, to which the MES contextual information is added before being sent to analytics and machine learning platforms. And the third level below is the operational level, in which we'll have samples, calculations, or aggregations of data stored in the MES. which then has the architecture that you might already be familiar with of having this online operational data storage and data warehouse, where we then report dashboards and decision support platforms working with these data sets. But again, just re-emphasizing the main point here is that all of these actual and future features are only possible if we have a completely integrated Connect IoT model instead of having a separated specific IoT platform. So that was my part. I think we'll have questions later on, but for now I will hand over to Bernardo. Bernardo, are you still there?
Yes, I'm still here. Very interesting. Thank you very much, Francisco. So thank you also for all of you who have joined us today, whether it's your first webinar with us or you've been part of the series of webinars that Francisco and Chris were mentioning. We are very glad to have you, and as it was said before, the purpose that we're pursuing with this series of webinars is attempting to add value to you as professionals in the automation and manufacturing world, and we want to show you how you can benefit from our critical manufacturing 4.0 and IoT ready application. And for this, we have put together a comprehensive partner program to help organizations and individuals who are interested in being part of what we're doing. And we understand, we know that it's important to have the right product, the right program, and the right partners. And as you may have noticed, we're very excited about what we're doing with our product. If you liked what Francisco showed us a few minutes ago, we are expanding our presence in the Americas, having a very solid presence in Europe and Asia, Pacific, and other parts of the world. We want to strengthen our presence in the Americas, and we're looking for the right partners. So we have put together a program that includes 4 different categories of how companies and individuals may join us in these efforts. The first one of them being a solutions partner, which is a full-blown partner responsible for promoting, marketing, and selling, implementing, and servicing and maintaining customers based upon critical manufacturing solutions. And we also have resellers who are organizations that are more interested in the sales side of the business only, not interested in diving deep into the services side and implementation and technical support. But in the other hand, we also have organizations that are specialized on providing the services only, not very savvy on the sales side. So we also have a flavor for this type of organizations. And the last but not least, we have a category we call consultant referral partner. This one's open for individuals, not only organizations, who are have spent an important number of years in the industry, who know not only people, but organizations that could benefit from solutions like the solutions that critical manufacturing is bringing to your attention today. And we do look for individuals as well who are interested in promoting these solutions and working with us in a very rewarding program. And we are targeting specific industries. So in first place, we are, as Francisco explained in the beginning, we were born out of the semiconductor industry, where we have a very complete solution, and we expanded from there into different industries and verticals, including electronics, specifically going to the printed circuit board. In the medical device industry, we have very important and successful stories that we can share. Also in the solar industry, in the automotive industry, and aerospace and defense. So for those of you who are part of this webinar today, who are part of this world of semiconductor, electronics, medical device, solar, automotive, aerospace, and defense, and see opportunity with our product, we'd like to hear from you, and we'd like to show you how easy it is to join our program. So on the next slide, you will see we have in our website, we have a portal where our partners can join us, and through it, we can share information on the different qualifications necessary to be a partner with Critical Manufacturing. I'm the main point of contact for that, and you can reach me at partnerinfo@criticalmanufacturing.com. We are very interested in hearing from you and answering your questions, even right now, if you have any. So you can join a very exciting and growing team of professionals passionate about bringing Industry 4.0 and IoT ready applications to the North American market. Chris, I pass it over to you.
Well, thanks, Bernardo, and thanks for Francisco and Bernardo for those great presentations, very detailed, excellent. So at this time, we're now going to answer your questions. So we actually have 4 questions that have come in, which I'll give to the speakers right now. But if any question is not answered due to any time constraints, we'll be replying to every question by email within the next few days. Even if you think of a question after this webinar, please let us know, and we'll be replying to those very promptly. So the first question, and this one is for Francisco, is for customers that have all equipment interfaces using PLCs and OPC, how do you see the use of IIoT? Francisco.
Yeah, thank you, Chris. This is a very interesting question because this is kind of the, I would not say the majority, but almost all, the situation with almost all manufacturers. So what I think is going to happen is that, the companies that are already fairly automated, different interfaces available, it will still be possible to take advantage of IoT devices because of the easiness of setting this up. Imagine the case in which, let's say, for example, within a given machine, there's a suspicion that there's say, a vibration element in a place where you don't have a sensor today, might have some influence on the yield of a certain machine. In the past, the way to do this was to talk to the equipment providers, to talk to the equipment manufacturers, so that they could place a sensor in that location. After that, we would have to make this data from this sensor available as part of the interface. And only then we'll be able to collect this information. And we are talking here in the majority of the cases of very large periods of time, months, if not even 1 year in some cases. And then at the end, we find out that, okay, there is no influence in the yield. Like, if we compare to the situation that you have today, using a very cheap IoT device, you could simply place it there, integrate it into the overall solution, test it for seeing if there's or not a correlation in this case to the yields. And then after checking this out, then you could easily, if it's worth having that, then you can easily work with the equipment supplier for having this standardized. But the use of IoT devices in such scenarios will give enormous flexibility in many different contexts of this type. So that's how I see in the near future in existing manufacturing environments that are already fairly automated, how it will be possible to take advantage of IoT at the equipment level. Then, of course, we'll also have the other side of the coin, this is the one that I showed before, which is the use of IoT devices within product explainers. And here we'll open up a completely new world unrelated to what we have today.
Okay, thanks for that. So we'll go into the second question. Again, for you, Francisco. Interesting question. I understand that you believe IIoT should be integrated into MES, but can an external solution still be used?
Yeah, it's a very nice question as well. Well, certainly, I mean, you can use any other external IoT platform and and integrate it with the MES, but there's a few things to have in consideration. Is first, there's a lot of work in terms of integration, which will not only have to be done once, but then maintained and extended. you won't be able to do this type of configuration of workflow automation in a central location. You won't be able to manage in the same way, in the same solution, the same central solution, both the standard interfaces and the IoT, and overall, you won't be able to centrally control the entire automation setting. So basically, yes, it is possible, but it's a lot of work, and with many of the benefits that we talked about, not really achievable, at least without a significant investment. So while it's possible that you think this is easy, it can be easily set up, you should really consider what are the advantages and disadvantages before doing that.
Okay, so that's a good segue actually into the third question, which is, again, for you, Francisco. Do you think that IoT automation can be done by non-technical people?
Okay, we have to define what technical and non-technical is in this context. So the persons that will set up the automation workflows, they need to be automation engineers. So they need to understand what they're doing. They need to understand what variables they want to read. They have to know what type of influence they want to have in the production. So they need to be automation engineers. When I mean non-technical, what I mean is they won't have to do programming. They won't have to do code. Automation engineers are persons that understand in and out everything about automation in the shop floor, but they are not necessarily IT programmers. And that's the beauty of the solution. It will allow persons that are automation experts to work with this and to set up all of these automation workflows without having to code.
Great, great. So we have time for one more question, and the fourth question is for Bernardo, if you're still there.
Yes.
So the question is, can I, as a consultant referral partner, participate in the services side of the business?
Well, that's interesting. We actually have a couple of consulting referral partners who have expressed interest in participating in the services before. Fortunately, all the effort that is required for training and certification, it's been designed for organizations that have a larger number of consultants than just a one individual. So what we've done in the past is we have worked with services and full-blown solution partners to work with that consultant referral partner in a separate agreement, so they can be part of the organization and therefore receive the training and certification required to participate on the services side, implementing and supporting our solution in front of the customers. However, this is on an individual basis, and we will have to certainly work it out, but it's doable. However, the general answer is to be a services partner. The qualifications require more than just one individual, but yes, we can work out around that.
Fine, great, thank you. So, Francisco, if you can just change to the last slide. I just want to go over this one. So thanks again, Bernardo, Francisco, for your excellent presentations, and thank you everyone for your participation and involvement in today's event. Before we close, I'd just like to inform you that we'll be hosting more webcasts in the coming months, which will focus on providing more detail on some of the functional capabilities that really differentiate critical manufacturing. Remember that this series is being recorded and has been recorded before, and all of those webcasts are available on demand in the resources section of our website. We also, as you see on the slide, encourage you to download 3 white papers which cover much of the material mentioned today in detail. The links provided on the slide that you see here will take you directly to the papers. They'll provide insights and education on the role of MES in Industry 4.0 and digital transformation. And I just want to make sure that you're aware of the last paper here, which is IIoT has a thing for MES, which explains in detail our position that MES is now more important than ever in the IIoT world. So thank you again for attending this third webcast in our series. We look forward to the continued engagement with you and serving the needs of your customers and your industries. So with that, this webinar will now close. Thank you so much.